says, suppose the formation of nitrosyl chloride proceeds by the following mechanism. And we have a first step and a second step. It says, suppose also that K1 is much, much less than K2. Said another way, the first step of the mechanism is much slower than the second. So the higher the K, the greater the rate, because rate equals K times the concentration of things. So if K1 is much smaller than K2, that means that the first reaction occurs much more slowly than the second. So let's first find the overall balanced chemical equation for the overall chemical reaction. So to do that, what we need to do is add these two reactions together. As you recall maybe from other videos or from Hess's law, to add reactions together, we simply write everything from both reactions on the reactant side and everything from both reactions on the product side on the reactants and the product side. So starting with NO gas plus Cl2 gas plus NoCl2 gas plus NO gas yields, and I'm going to write it down here, NoCl2 plus, that's a gas, sorry, plus 2NoCl gas. So I wrote all 1, 2, 3, 4 reactants, 1, 2, 3, 4 reactants on the reactant side, and both 1, 2 products, 1, 2 products on the product side. So all reactants on the reactant side, all products on the product side. Now cancel out like terms. It looks like in this case, the only like term is the NoCl2. So it hasn't changed. It was NoCl2 on the reactant side, it's NoCl2 on the product side. That's not chemistry. Nothing happened, so it shouldn't be in the chemical reaction. Also, in this case, we can combine like terms because we have an NO here and an NO here, and we don't generally write it that way. Instead of writing it that way, we would write 2NO gas instead of NO plus NO plus Cl2 gas yields 2NoCl gas. So to review, we crossed out anything that was the same on both the reactant side and the product side, and we combined like terms. So instead of NO plus NO, we just wrote it as 2NO. And this is a balanced chemical equation. We don't need to do anything to balance it because the intermediate elementary reactions were already balanced. Next, we have to go back to this. Suppose that K1 is much less than K2. That is, the first step of the reaction is much slower than the second. And it says write the experimentally observable rate law for this overall chemical reaction. So these are the elementary reactions, meaning that you can write the rate law directly from the elementary reactions. But the question becomes, do we use this elementary reaction, the first one, or do we use this elementary reaction, the second one, in order to write the rate law? And this is where the first step is much slower than the second comes into play. So as a practical example, let's assume that we're trying to bake 10 dozen muffins. And they had the proper equipment, so it was like a professional kitchen or something, to make the batter. But they only had a household oven. So in this case, they could make all the batter for the 10 dozen muffins in probably 10 minutes or 15 minutes. But then, if the muffins take 20 minutes to bake a piece, and they can only fit a dozen muffins in their oven at a time, they now have to do that step 10 times for 20 minutes a piece. It's going to take hours to make all of the muffins. That is the slow step. That is the rate determining step. It doesn't matter that they can very quickly make the batter. It matters that they can only slowly bake the muffins. So this is the same thing here. In this case, the first step takes a long time, and then we can consider that the second step happens essentially instantly. So the rate of the reaction is dependent only on the first step, not the second step, because the first step is the slow step, just like baking the muffins in my example was the slow step, which determined how long it would take to make all the 10 dozen muffins. So we want to write the rate law for the first step of this equation because it's the slow one. Since it's an elementary reaction, we can just write it directly. Rate equals K, concentration of NO. There's only one of them, so it's to the 1. We don't have to write it. concentration Cl2, which again, there's only one of them, so we don't have to write it in our rate law.